Hello, chemistry students. We are still in Unit 2, Toxic Tides, the unit that's all about water. And this is Lesson 2, Part 2, which is clearly just talking about classifying elements or classifying matter into various categories. So what are we going to do by the end of this PowerPoint? We're going to be able to differentiate between pure substances and mixtures. And as far as mixtures go, we're going to be able to differentiate between homogeneous and heterogeneous mixtures. We're also going to differentiate between elements and compounds, and we'll throw a few other categories along the way. So matter, if I look at everything in the world that is made of, that has mass and takes up space, has volume, everything in the world is matter. So anything that has mass and takes up space has volume. Anything that has both those characteristics, it's going to fall under one of two categories. It's either pure substance or it's a mixture. Pure substance has just one element or one compound in it. So if we were to say diamonds, diamond is just carbon atoms bonded together. We can say deionized water, it's just water, H2O. We can say table salt. Table salt is just sodium chloride. One thing. But that one thing can be either an element or a compound. So if I look at my pure substances category, I have first category is the elements. It is the simplest form of matter. It is literally the period. If it's on the periodic table, it's an element. It's called the periodic table of the elements, by the way. It's the most simple version of the atom, and they're the building blocks. Some examples would be iron, sodium, carbon, oxygen. And even though oxygen is a compound, technically, it is O2. Oxygen only exists in diatomic form. It still qualifies as being an element. So, misconception does not mean that the element in nature is always a single atom. Hydrogen is diatomic also, just like oxygen. As a matter of fact, let's get ahead of ourselves. The elements that are diatomic are B, R, I, N, Cl, H, O, and F. The acronym that gets used is Brinkelhoff. All of these elements, when they are in nature by themselves, will exist in pairs because these guys are just that reactive. Brinkelhoff. The other category of pure substances are compounds. Compounds are when you have a combination of two or more elements, and they are combined together, and this is the key, in a chemical reaction. Okay, you're going to have a chemical bonding between the elements, and each one of these compounds has their own unique characteristics. So some examples might be water. Now, talking more about tap of H2O. Or salt, NaCl. Carbon dioxide, CO2. Those are all compounds because they consist of two or more elements joined together, but they're bonded chemically. So, what do you think is the difference between an element and a compound? Is it an element is a single atom and a compound is more than one atom? Is elements found in rocks and compounds are found in man-made materials? Or is it elements contain one type of atom and compounds contain more than one type of atom? Well, the correct answer is C. So if we look at these categories, we've just done this. We've said matter, right here, can be broken into pure substance or mixture. And if we're on the pure substance category, it could be either an element or a compound. Let's go over to mixtures. So if a pure substance has just one substance in the sample, a mixture would have more than one. And these are physically combined. So these are not chemically combined. This is a physical combination. there is no bonding between components of a mixture. They can be separated by physical means, like this trail mix down here. You could pick out the cashews and pick out pick out the raisins, and you don't have to do anything chemically to break it up. You just grab the pieces. That's indication that it is a mixture. If it can be can be separated with a physical means without breaking any bonds, then it's going to be a mixture. There's two types of mixtures. There's homogeneous and homogeneous. Those are ones that have a very even distribution. So for instance, mashed potatoes, good mashed potatoes, not ones that are all clumpy, but good creamy mashed potatoes would be a homogeneous mixture. You can't see all the parts in there. You know that it's got potatoes and butter and salt and maybe pepper, maybe some other secret spices that you do for your mashed potatoes. But you can't see the different parts, so that's going to be a homogeneous mixture. It all looks the same. So for example, Kool-Aid is a mixture. But wait, is the Kool-Aid also a solution? Well, that's right, because solutions are a type of homogeneous mixture. How solutions are different than every other homogeneous mixture is you're always going to have two distinct parts. You're going to have the solvent, that's the thing that's doing the dissolving. Solutions, one thing dissolves in another. And you're going to have the solute, which is the thing that's being dissolved. So in the case of Kool-Aid, you would have the flavor as a solute. You would have maybe the sugar as a solute. And you would have the water as the solvent, the thing that's doing dissolving. Or tea, same idea. You have the tea component, the tea parts are going to be dissolved into the water. So that means you've got a water as your solvent. Sorry about that. Okay. So some solutions might look like this, where you're dissolving some sugar or salt into the water. The thing that's being dissolved is a solute. The stuff that's doing dissolving is the solvent, and the mixture together is called a solution. So it's a special type of homogeneous mixture. Another special type of homogeneous mixtures are things called alloys. Now, alloys are a mixture, but they're mixtures of metals. Two metals that are melted together, placed into their liquid form, mixed together thoroughly, and then allowed to combine physically, not chemically. So some examples of alloys would be brass, bronze, steel, and solder. Those are all things that are a combination of two different metals, or in the case of steel, a metal and a nonmetal. They're going to be a solid. It's going to be something that looks like a normal metal. It's just going to be a mixture of two metals. Okay. What about the heterogeneous side? Well, a heterogeneous mixture is one where you can see the different parts. So here's a taco. This taco, you can see the cheese and lettuce and tomato, sour cream, ground beef, the shell. All the parts are distinguishable. That means that they are going to be a non-uniform mixture. You can see the different parts. That's going to be a heterogeneous mixture. On a microscopic level, the comparison varies throughout. Maybe the particles are different sizes, uneven distribution, but you're going to be able to definitely see the differences. And we go back to our trail mix. They can be easily separated because we can see the parts. So here's an example. We have on the left, we have copper and zinc. And on the right, we have granite. The copper and zinc, it just looks like one yellow metal. You can't see the copper atoms and the zinc atoms, but they're mixed together. But in the granite, you can definitely see different parts. You can see it's broken up into a bunch of little colors and dark spots, light spots. That would be a heterogeneous mixture. A special type of heterogeneous mixture is a suspension. A suspension is one where the particles form layers. So it's mixed together, but not. You can shake it up, mix it up, and then it'll settle into layers. A typical example would be muddy water. This thing down here, muddy water. You mix that up, it looks like one big brown blob of yuck. Let it set. Some of the more solid soil will fall to the bottom. Some of the lighter soil will float to the top, and you'll see a layer. Pizza is also a suspension. You've got this layer of the pepperonis and the cheese and the layer of the crust, layer of the tomato sauce. Probably the one that's most recognized is Italian dressing. Italian dressing, when you get it, you can see its layers. It's got a oil layer, it's got a vinegar layer, and you see usually can see something down here of the particles, the herbs, and before you use it, you shake it up to make it all one big suspension. Then when you're done, you set it on the counter and it separates out again. That would be what suspensions do. You can shake them up enough to mix them for a little bit of time, but then naturally, because of gravity, they're going to fall down. And the last odd type of heterogeneous mixture is called a colloid. Now, colloids are kind of neat. Colloids are where you have the particles that are in the mixture. You can't really see the layering, but they could be separated. And one of the ways to tell whether or not it's going to be separated is something called the Tyndall effect. I'll show you that in a second. So, for example, smog, smoke, air, any dairy product, they're all going to have some sort of particles floating throughout. They're not going to settle out. They're going to be floating throughout. And you can see that there's definitely a mixture that you can't see you can't see the individual particles, but you know they're there. One of the reasons why we know it's there is something called the Tyndall effect, and we'll see whether I get in trouble with YouTube here.
Check out this cool experiment. I'm trying.
Okay, so I'm going to stop right there. So see the beam of light go through this one on the left, and you can't see it, but on the one on the right, you see the beam? That's called the Tyndall effect, when you can shine light through and you see the beam. When we go back to the previous slide, you talk about fog or smoke. Smog, fog. If you ever drive in fog, you can see you're in dark nighttime with fog. Your headlights will show a beam, and that beam is the Tyndall effect bouncing off of the water droplets that are in the air. Go past this so I don't get in trouble. Okay. So minerals, are they pure substances or mixtures? Well, let's just say minerals make up the Earth's crust. We talked about that in the last section. But these are always combined with some other element and are made as compounds. So we have these 8 most significant elements that are almost always combined into some sort of a compound. And those minerals, they're usually occur naturally in the Earth's crust, and those compounds will sometimes, not always, but sometimes will be a part of a heterogeneous mixture. So here we got a rock. It's formed by the minerals. The minerals themselves are elements combined together, but you can see when they mix together, they don't mix very smoothly. You get a bunch of different types of particles, and this would be a heterogeneous mixture. So from a visual, pure substances, one thing, only blue, only black, 2 reds, only 2 reds, only red, 2 yellows. Mixtures, a homogeneous mixture, they would be thoroughly spread out. You can't really tell where one set combines, the other doesn't. Whereas a heterogeneous mixture, you would see, hey, all the black things, all the black atoms would be on the bottom, or in this case, all the purple atoms would be off to one side. So you can definitely see a flow. And then to reinforce, states of matter, gas, liquid, and solids, and chemical change is when you have a chemical reaction take place that changes the orientation, changes the bonding, or a physical change where you just simply break it apart into its pieces. So to review, we're going to do a kind of a Kahoot. So let's do this. Which one of these two is a mixture? Is it the baking soda or is it the orange juice? If you pick the orange juice, you're correct. Orange juice is a mixture because it's a juice and can be separated, especially if it has pulp. You can see the particles. Is it heterogeneous or homogeneous? Well, that's a good question. If I can see the pulp, then it's going to be heterogeneous. It's not uniform. Okay, let's look at these two. Iron filings or the Pacific Ocean? Which one is a mixture? A dead giveaway over here is iron filings is Fe. That's just saying it's an element on the periodic table. As opposed to the Pacific Ocean, if you got all those fishies out there, you can see that they're all mixed together, the fish and the salt and the sand and the squids and the octopus, whatever. They're all over the place. So Pacific Ocean is a mixture because there's more than two substances, and they're separated through physical means. Is that going to be heterogeneous or homogeneous? Well, depending on how you look at it, but in our situation here with the fish, that would just definitely be heterogeneous. It's not uniform. If you had just salt water or just the ocean water, it might be different. Okay, let's look at this pair. Which one of these two is a pure substance? Is it helium that's inside the balloon, or is it salt water? Well, since salt water is you're adding salt to water, that would be a mixture. That means the helium is going to be a pure substance. And salt and water is a mixture. And is the salt water a homogeneous or heterogeneous? That's going to be a homogeneous mixture. How about that helium? Is that helium going to be an element or a compound? Well, helium is an element on the periodic table. Letter number 2, He, so helium would be an element. Which one of these two is a mixture? Is it chromium or brass? Well, brass, we already know. They give us a help here. It's copper with zinc. The copper with zinc would be a mixture. Brass is a mixture because there's two substances. Is that brass going to be homogeneous or heterogeneous? Well, it's going to be homogeneous because you can't really see the individual atoms or even broken into sections. Which one of these is going to be a pure substance? Is magnesium or tap water? Well, magnesium is going to be a pure substance, and tap water is going to be a mixture because tap water, there's more than two substances. The substances can be separated. Whereas the magnesium, it's one thing. Mg. Is the tap water homogeneous or heterogeneous? Well, that's going to be homogeneous because you can't really see the parts, but you know they're there. And magnesium would be an element because magnesium is on the periodic table. So a little bit of practice in looking at different components and deciding whether or not they're homogeneous or heterogeneous, mixture or compound. Hopefully that helps a little bit. When you're doing the homework, if you have any questions, please don't hesitate to ask me or your friends. Until next time, toodles.